Hi friends, welcome to the quantum realm of mysteries and magic. Well, you might be wondering what's a quantum. Let me clear that for you. Quantum defines the science behind nature and the nature behind science itself. Let's understand that in an easy way using a simple analogy. Everything in you, me, all living and non living things, not just that, everything in this universe is made of quantum particles. But you might ask, then what about atoms? All of us are initially said to be made of atoms, right? Yes, all of us are made of atoms. But the atom is also made up of smaller particles called electrons, protons, and neutrons. Electrons are are fundamental in their state, and they cannot be made of other particles. They are the smallest existing particles of their kind. If we come to protons and neutrons, they can be further subdivided into quarks. They have other complications like spin, and let's not go to that now. Let's come into the brief understanding of quantum and dive into the quantum world. You might be familiar with this. This is an electroscope. But for the sake of others who do not know this, let me just give a brief explanation about this. The rod at the top of the image conducts a small charge. The charge in the rod is given by an electrostatic force between any cloth and the rod. The rod then is put onto the disc. The disc is a conductive surface that is connected to another conductive rod which is further connected to a leaf-like structure. When the rod is kept on the disc, the positive or the negative charge, it's not important to talk about the charge because this is not the device that determines or differentiates between positive and negative charge. It just tells us the existence of a charge. So that the type of charge is not important. The charge, it travels from the rod to the disc, from the disc through the conductor to the leaf, and there are two leaves present in the jar. The two leaves are of the same charge. We know by electric and magnetic forces that the same charges repel and opposite charges attract. These two leaves are of the same charges. So instantaneously you will reply that they will repel. Yes, they will repel. So as the charge increases, the distance between both the leaves increases and they further repel each other strongly. With this concept, let's go to our next topic. The scientists used an electroscope in order to perform an experiment. The electroscope used here is called the golden leaf electroscope. What is the significance of this electroscope? Let's discuss that first. This electroscope, the leaves in this electroscope, the speciality is in the leaf. The leaf is made of gold and it's so delicate that even the slightest of charge can be detected by the electroscope, and a very small change is made in the repulsion by the slightest of the change in the charge which is given to the electroscope. This is why the golden leaf electroscope is used especially during experimental analysis. Now, scientists had put a negative charge to the electroscope. Then, the negative charge travels to the leaves and the leaves repel. According to the scientists, if a light of a positive charge is put or incident onto the disc, then the charge goes through the conductor into the leaves. The positive charge and the negative charge neutralize or you can say they nullify each other, and the leaves are now the leaves do not have any charge now, so they collide with each other or they attract or they come to their initial position. So the scientists thought that they could check they could test for the charge of the light using this experiment. Yes, they did try the experiment using tungsten filament. The tungsten filament is a special type of filament that can resist large amount of current, can produce large amount of heat, and can produce light along with that. This filament was used to was tested on this electroscope first. When this filament was used to test the electroscope, they first put a small charge. It gave a red light, but the light could not remove out or knock out the electrons. So they increased the current. The filament became yellowish in color, and the light emitted was yellowish in color. But still the electrons were not knocked out. They were surprised, and they increased the current even more. Now they saw that it was a complete white color light, but even now the white light could not knock out the electrons in the electroscope. The electroscope remained unchanged in its nature. After several years of experimentation, scientists came up with an idea of testing blue UV light in the same experiment. Instead of the tungsten filament, they used the blue UV light creating bulb and tested whether this is of a positive charge. Well, they were shocked to see the result. It completely knocked out the electrons in the electroscope, and not just that, it knocked it out within seconds. That was the astonishing thing. That means UV light was very strong and highly positive in nature. This was very mysterious to the scientists of that time. So now let's talk about the light, the tungsten filament. I talked about the white, yellow and red light. So I want to explain a little more about that. The white light is the white light is produced in the leftmost picture that you see, yellow light in the center picture and red light in the rightmost picture. Well, there are several experiments conducted in modern day research, and the results are such that white light is produced when the tungsten filament is almost 2000 degrees Celsius. That's very hot. Yellow light around 850 degrees Celsius and red light around 300 degrees Celsius. All of these values are experimental results. There might be small errors in them, but they are approximately correct. Now, with this analysis or with these values, we can clearly see that the temperature increases. When the temperature increases, the color gets whiter. Red becomes lighter in its color and it goes to yellowish color. Yellow becomes lighter in its nature and becomes whiter. So, when the current increases, the temperature increases and the color gets whiter and whiter. But after scientists had used various current values to get various different colors, they observed one thing. The tungsten filament could not produce the blue color UV light. The red light got lighter and lighter, and finally the tungsten filament stopped producing light as the current got lower and lower. But as the current got higher and higher, the white light became brighter and brighter but never blue in color. This astounded the scientists of that time. Well, this was a difficult problem because the scientists had to produce UV light. UV light could be produced with another way, but they did not understand why not with the tungsten filament. This was coined as the ultraviolet catastrophe. Well, this pulsed the scientists for a long time. Later, Max Planck, the father of quantum mechanics, gave a mathematical relationship between the color of the light, the frequency of the light, and the energy at which the light can be produced. For this achievement, he had been given a reward. But he not just stopped with that. He went on further and he gave his hypothesis that light was made of smaller particles called quanta or quantum, and that light was and that blue light was made of heavier quanta than that of white light. But he himself was not sure of a good and reasonable explanation behind the ultraviolet catastrophe, even though this was in his mind. He felt that his explanation was not so relevant and so good enough to explain the ultraviolet catastrophe. Well, we have already discovered that Planck has introduced the concept of hypothetical energy quantum to explain the black body radiation spectra and the ultraviolet catastrophe in the 20th century. To be precise, 1900. Later, a patent clerk commented the utility of the quantum theory through an explanation of the photoelectric effect. The photoelectric effect, which I had earlier explained to you, was that wasn't the uh, why wasn't the blue light produced in the tungsten filament? This theory was explained by the patent clerk in a paper in the year 1905. This clerk was none other than one of the greatest scientists of his time, Albert Einstein. With this in our mind, let's dive into the quantum mechanics. One of the core concepts of quantum mechanics is quantum entanglement. Well, quantum entanglement deals with two objects or two quantum particles of the same size, of the same material, of the same mass, and they should be in motion. If all these conditions are satisfied, then they then quantum entanglement says that the particles remain connected in such a way that the actions performed by one particle affects the other, or the fates of both the objects are intertwined. Albert Einstein called this spooky action at a distance. Well, later this theory was given by Bohr, a famous scientist of his time. But Albert Einstein later argued with Niels Bohr on this theory because of a specific reason. That reason was Albert Einstein said that in his theory of relativity, Albert Einstein specifically said that nothing could go faster than the speed of light. But according to Bohr's quantum entanglement theory, any two objects could be uh, in motion of the same size and they should be of the same material, then they will be interrelated, they will be intertwined or connected in such a way that their fates are intertwined, and when one action is performed, immediately a specific almost spontaneously the connection gives an opposite reaction to the other object. This was against Albert Einstein's theory of relativity. That is why Albert Einstein argued with Niels Bohr. As I told you, two particles should be of the same size, mass, and they should be in motion in order to be entangled. Even though the particles are at a great distance, for us several kilometers, but you can also consider them to be at the two ends of the universe, and then still the result will be the same. The connection will not be broken, the result will be spontaneous, and the result will be always opposite. Einstein had argued for several years because this was against his theory of relativity that was world renowned. Thus, he argued with Niels Bohr for several years on this fundamental of quantum theory. Well, later he debated on a fact in the Copenhagen interpretation, which had its main core concept as entanglement, as we all know. Einstein said that Einstein had a vision that or a perception that of entanglement. He hypothesized that we could take two boxes of the same size, take two gloves of two hands, one right-handed glove and a left-handed glove. Without seeing which one is right and which one is left, he puts both the gloves into both the boxes. Then he says that until and unless you open a box, you cannot determine what is the glove inside the box. If that is the condition, then you can open a box and take the glove. If the glove is left-handed glove, you can for sure determine that the other box has a right-handed glove. He says that quantum entanglement is something similar to that, and that if one quantum particle gives one action, then it's sure that the other particle should give the other reaction. This he used to prove this. He used common logic, but Niels Bohr says that common logic is not. It's not so easy. Entanglement cannot be proved by using just common sense or common logic. It is something which had been puzzling scientists for a long time and will puzzle scientists because it is a mysterious communication between two quanta which are in entanglement. Both of them had argued for several years. The physics community was confused because these two scientists were one of the greatest of their time. The theories were strongly these theories were strongly supported and were against one another. Later, John Bell, one of the greatest scientists of his time, proved that Einstein was wrong. John Bell is a scientist who had done several experiments on this entanglement using the techniques of that time, which are even followed today, to prove that Einstein was wrong. He also coined his own equation with regards to his explanation and his experimentation. So here's my video about quantum entanglement. Hi friends, I am Lalit. Today I am going to verify the experiment proposed by Niels Bohr. Let us consider these two coins to be two quanta particles rotating at a distance d. So the distance d can be as large as possible or as small as possible, but the experiment will work out. Now let us see the experiment. Now, as you see, I have rotated the two coins and they are spinning. According to Niels Bohr's hypothesis, the coins should be of the same mass and of the same size. Then the coins are said to be entangled if they are in motion. Now, if you see, one of them is a head and the other is a tail. So we have successfully verified Niels Bohr's experiment. Thank you. Thank you.